Good morning. Hi, my name is Mario, and today we're here with. Okay. Good morning. I'm Mario, and today we're here with 2-Bit Circuits Foundation, and it is our playful learning hour. And today I'm going to show you how to make a magnetic light. The materials we need for today will be 2 wires, a reed switch, and an LED. So I have 2 types of LEDs here. And this is one I will be taking apart shortly. We'll need a battery. It could be a 9 volt or a 3.5 battery like this one. This is a 3.2 volt, which is the coin cell battery, and a magnet. So we're going to go ahead and get started. And let's see. So we'll first get started by ripping this apart and taking out the insides of it so I can show you. So you can purchase these at like the Dollar Tree, and they have the materials you'll need besides the reed switch. So let's see. So in here we have already a magnet, so you can actually use this magnet yourself. So I'm gonna go ahead and pry this open. So you can see it pops out very easily. So right here is a neodymium magnet. So there's 2 kinds of magnets that they have. So this is a nickel magnet, so you can tell the difference. One is more shiny and the other one's more dull in color. Let's see. We'll put that down. And we're going to continue taking this apart so we can go ahead and get started. Let's see. I'm pretty excited. Let's see. So we need to pry this open. Let's see. Alright. So once we pry this open, we'll find the insides of the light. So there we go, we popped it open. So on the inside of the light, you can see there's already a switch. Let's see. The magnet came out of the inside of this push switch that is magnetic, and you could purchase at the 99-cent store or any other retail store. So it came out of the back of here. So it was popped inside, but I popped it out, so now we have a magnet that we can use for this project. Oh, and it broke. Alright, so now we're going to take this apart more. So I'm going to go ahead and remove the inside of the LED and pop it out. So actually, first I'm going to check and make sure this LED works. So I'm going to use this 9 volt battery and make sure it works. So down here you can see which one is negative and positive. So you have to make sure when you're plugging the battery, you plug it in the right polarities. So right here it says this side is positive and this side is negative. So we're going to go ahead and flip it over. And so the side that's gray and white is the positive and the white side is the negative. So we're going to go ahead and plug it in and make sure this LED is working. Let's see. So as you can see, the LED is working, so we can go ahead and move on to our next step.
Do you want to grab
Yeah. Alright. So we're going to go ahead and open this more and continue on making our magnetic light bulb. So let's see. I'm going to open this up a little bit more. Let's see. I'll pop this out. Alright, so now that it's loose, now I can go ahead and grab the soldering iron. So while using a soldering iron, I will recommend adult supervision or an adult doing this for the child or anybody who wants to do it. So you can find these at any hardware store. They are called soldering irons. They go for about 15 to maybe $100, but any other like soldering iron will do and it will work. So we're gonna go ahead and unsolder these joints here. So I'm gonna show you what I'm gonna unsolder. So as you can see right here, I'm gonna unsolder these joints here. And it's very important to remember which one is positive and negative. If you don't remember, you might short something out. Alright, so I'm going to go ahead and unsolder this. Okay, let me make sure it's on. So it is important that you make sure that your soldering iron is hot. And so if it's not hot, it's not going to melt the solder that's already holding these joints together. So as you can see, these joints here, it's not going to be able to melt them as fast. So you have to wait it to heat up to a certain amount of temperature. Let's see. Let me make sure it's warm. Let's see. So I'm gonna go ahead and try to desolder this. Alright, I got one side off. Now to take off the other side. Alright, so I successfully removed them. So now we have these two prongs here. Remember, white is negative and the other side is positive. As you guys can kind of see. Alright, now I can get rid of this. I no longer need that. So we're going to move on to our next step. So we're going to start to attach the reed switch into the circuit. So what is a reed switch? So a reed switch is a magnetic switch. So if you have a magnet, I'm trying to see if you guys can hear it or see it. There's two pieces of wire there. So when a magnet goes by close to it, it'll click together. Let me see. It's not clicking. It's like a light click. So let me do an example with my hand. So when you bring the magnet together, or let's say the magnet's on the front, and when the magnet goes in front of it, the metal in the back pushes forward. So it makes a connection. So it makes contact and it lets the circuit flow. So once it does that, it completes the circuit. So that's a reed switch. Let's see. Okay. Alright. So we're going to go ahead and solder that. So when you're soldering, you have to make sure to prepare the tip. So I have to put some solder in here so I'll be able to make a connection. So I'm going to go ahead and prep the tips for that. Let's see. I'm going to go ahead and grab my soldering iron and prep the tips. Let's see. So when prepping the tips, you want to make sure you have a little bulb, at least of solder, just like this, if you guys can see it. It's a little bulb just like that. And this makes sure it helps when you're making your connections. So these wires already have some solder on there, so I don't need to do that to these. So basically when it has solder, when I heat it up, it'll stick just like glue. So I have a very strong connection. So let's see. I'm going to go ahead and do the other side. So the age for this project, I would say probably 12, 13. Because then they'll be able to handle all this stuff on their own. They'll know how to solder and be safe with it, I assume. Let's see. I'm going to do the other side. Alright. Alright, so now we're going to hook the reed switch on the positive side of the LED here. So we're going to go ahead and solder this together. So let's see. Let's see. This is not one. Let's see. So I'm having difficulty right now, but it's nothing that I can't work with. So I just finished soldering this. So as you guys can see, now it has a solid connection. So it's solid now. Alright, now for the negative side, I'm going to solder a black wire so I won't get confused or you guys won't get confused. So this would help on identifying which one is negative and positive. So I'm going to go ahead and prep this side as well. So prepping it, again, it makes it better and easier to solder, and it makes the job much more easier and less difficult. Let's see.
So for our viewers who are tuning in right now, can you recap what's on your project about today?
So today we're actually making a magnetic light. So what that means is this light, whenever you put a magnet next to it, it's going to light up. So there's a lot of people that use this idea on like actual light bulbs like this, but they're slightly larger and they're able to get into the inside. So when they get into the inside, they're able to create like an illusion, a magic trick. So what they put inside would be a battery like this, a coin cell, and they're able to put it inside. So they'll gut the inside of this battery and they'll purchase much more smaller reed switches than this. So I'm using this one so you guys can have a better visual of what the reed switch is and how it looks like. So when they have all that stuff together, they put it together, and basically when they have a magnet, they'll put it next to each other and make people believe that somehow that it lights up on its own by using a magnet. So it makes people believe that magnets give the light bulb electricity or some source of energy. But I'm showing you guys the inside of that trick so you guys can go ahead and make it yourself, or you guys can get creative and make some other kind of trick, or have fun with it. Alright, so that's that. Let me just finish prepping this guy over here real quick, and then we'll continue. Let's see. No. So, I already prepped this one. This one has a small bead on there, so it'll be easier to connect. So I'm going to go ahead and prep the other side and make another bead. Let's see.
So someone made a comment, starts on and said, can you mount this on your drone and fly it around later?
Can I mount it on my drone?
Yeah.
Currently, no, I don't have my drone on me, but that sounds like a fun idea, and I would actually try that out. So maybe next time I'll post a video of me doing that or trying it. So yeah, we'll keep you updated on that. Let's see. So now to mount the negative side, I'm going to go ahead and heat up both wires and make sure they connect. Alright, move that out the way. So now we have a solid connection, as you guys can see. It's a solid bead. You guys, usually it's good to pull and tug on it to make sure you have a solid connection. So that means you have a solid connection if it doesn't break and you pull on it. Alright, so now we can go ahead and actually connect our power source to it. So we want to make sure that these also have solder on them, so it's easy to make a connection. So they currently do not have any solder on them. So they'll need some solder. I'm going to go ahead and prep them. What things have...
Do you think using a soldering iron is good for an 8-year-old? Would that require like adult supervision too?
Well, I would say it might not be safe, but I would say with adult supervision, anything is possible, and I think it'll be fine with a child that's 8 years old. I think it'll be a great way to get them started on learning how to solder, because then they can get on to doing various projects and electronic projects. So I think that's not a bad age to start. So that'll be pretty cool to see an 8-year-old soldering. Yeah, it's not that dangerous as long as they don't touch the tip. So this is the most dangerous part here. So you want to make sure you don't touch it or try to do anything to do contact with your body or skin. So you want to make sure your hands are always away and a safe distance from the soldering iron. So I'm going to go ahead and prep these sides. Let's see.
What made you become involved with engineering or electronics specifically? Is this something you want to do long term, or is this just like a hobby of yours that you find fascinating and do during your free time?
So what made me do engineering? Well, back in high school, I was in an engineering class called Project Lead the Way, and Project Lead the Way is an engineering course that high schools provide, and it lets kids get involved with engineering projects such as like robotics or any other cool thing. So in Project Lead the Way, the first year you take it, the kids will learn how to create computer animated uh, computer animated design. So what that means is you're able to create computer generated graphics or designs. So when you're doing that, let me start this real quick. So basically, what that means, you're making objects in a 2D space. So in that platform, you can create a light bulb or anything that comes to your mind, which is pretty cool because there is no limits when you have a software like that, or like the class that shows you how to create all that cool stuff. Um, so that year, you're able to make a lot of stuff, and then it gets hands on. So the design you create on the computer, you can bring it to life and actually 3D print it. So I think that's really cool because it brings new opportunities to you and your imagination. Because your imagination, you have no limits. Let me just start this and I'll continue talking. Let's see. Okay, that's good. All right, so as I was saying, the first year, you learn how to do all that. That year, Project Lead the Way didn't really get my attention. It wasn't really my how do you say it? My it didn't really have my attention. So the next year was robotics. So that year, that's when things got more hands-on. I'm not the guy that likes sitting on a computer and designing stuff. I'm more hands-on, and I love making stuff like this. So that year, we were introduced to robots. So everything's much more hands-on, coding and all that. So that year, I got way more involved, and I started to accelerate in it, my class. So my teacher was pretty well happy about that, and it made me feel like I could do a lot of stuff, and it engaged me more in school and made me want to go after a lot more things. So yeah, that's pretty cool. And then the other years, they're aeronautics, the I forgot the name of the other one, but it's called the capstone. So in the capstone, you're able to create your own project. So in the capstone, you're basically creating an idea of yours, but it has to help the community or help some group of people. Like, I believe there was a group that created, what was it? I think it was a motor for a wheelchair to help people with a wheelchair to like move along without them struggling or pushing. So I think that's pretty cool, and it helps tap into kids' minds at a young age to create something, and it could eventually end up helping people in the long term. Let's see. So I'm currently testing the LED, and let's see. It's not working from what it looks like. So I might have did something wrong here. Might have the wrong polarities, so it could be in the wrong spot. Or let's see, to make sure. Maybe the battery's dead. So this is a part of the engineering process as well. You always run into problems, and you always have to debunk them. And running into problem isn't always such a bad thing. I think it's a good thing because you end up learning from it and you expand from it. So let's see. I don't think the read switch is clicking. There we go. So as you guys can see, it's not working. Okay. Interesting. Okay, so I just find out that if you put the magnet in the center of the reed switch, it's not going to pick it up. But if you go further to the side, it picks it up. That's pretty neat. All right. So eventually, once you have this completed, my recommendation is to cover these so they want connect or make contact. So if they make contact, it won't be such a good situation. You'll end up burning out your LEDs, your reed switch, or end up seizing the battery. So the best way to do this is, what I like to do is use hot glue, and I'll cover these in hot glue. So I'll cover all of this in hot glue, because if these make contact, so currently I don't have a battery connected, which is real good, but if these connections were to go like this, that's not good at all. It'll short out the circuit and also burn out your LEDs. So we're going to prevent that by actually using hot glue, and we're going to cover these in hot glue so they won't do any connections as that. So we're going to go ahead and cover that up. So I have my hot glue gun here. Using a hot glue gun, I recommend supervision by adults so kids won't get burnt. So while using the hot glue gun, I recommend having a safe distance from your hand so you won't burn it. So let's see, I'm going to go ahead and glue this. So there's usually a small bead covering the metal. That's good enough. So you want to make sure you go all around and you cover the metal with some glue at least. Alright, going to go ahead and cover the other side now. It's fine if you have like little webs crossing to the other connection. It's totally fine. It doesn't do anything with the interference of the wiring or the electricity. It's completely fine. We're going to go ahead and let that dry. And now we're going to go ahead and do the other ends. So get that done and over with. Let's see. Alright, that side's nice and covered. Usually it takes about 2 minutes for the hot glue to dry. So you guys can give it time and let it dry, or you guys can try blowing on it to dry even faster. So I'll blow on it so it can dry a little bit faster. Alright, so it feels kind of dry. So as you can see, it's covering the wire now. So now it's a little bit more protected. It's insulated. If you don't have any hot glue, you can go ahead and use electrical tape or heat shrink. Heat shrink is, let me see. It will look something like this, but it's going to be more of a rubbery plastic. So heat shrink, when you have it over the wire or the connection you're going to cover, you want to make sure it's over it. And so what the heat shrink does, once it's heated up, it starts to shrink and it secures the connection that was exposed tightly, and it makes it much more safer to do. So alright, so now that looks fine. All the connections are good. They're covered with hot glue, safe. They're ready to go. So go ahead and test it again. Make sure everything's working. Let's see. Oh, it's working. Alright. So since it's working, since I don't have a light bulb that I can get into, and since my reed switch is really big and I don't have anywhere to put it, I'm going to put it inside this material here we have at 2-bit circuits. It's reusable plastic that we have here. It's a P-cup. So I'm going to go ahead and try to put this inside here. As you can see, it's not going to fit. So I can go ahead and try another item that we have here at 2-bit. So I saw another container behind me. That's pretty big. So it might work. So this is another reusable item that we have here at 2-bit circuits, which is pretty cool. So this actually might work for our thing here. So I'm going to go ahead and put this inside. Let's see. Put that inside here. There we go. And now we see light. So usually inside the light bulb, like this one, all this stuff, the components inside will be hidden inside a light bulb like this. Usually the light bulbs that you're able to hide stuff like this, they're slightly larger. They're about, I want to say about 5 inches wide, so it's kind of massive. It's like a grapefruit. And they usually use those to trick people. So we can go ahead and check this one out. So this is basically my light bulb. I wasn't able to find a light bulb like this that was massive enough to hide all my insides. So we can go ahead and test it. So, oh gosh. So as you can see, the magnet is actually turning it on, which is pretty neat. So they use, like for other lights, they use like photocells or any sensor. So I'm going to show you guys next on how to make another kind of light without using the reed switch. So the next component that I'm going to show you is not a reed switch, but it's called a photocell. So a photocell basically is this guy over here. So this is a photocell. Can you guys comment in the comment section and tell me, what do you think a photocell is? So let's see. Any comments coming through? Let's see. Let's see. So for this one, for making this light, once you complete this circuit, you can actually use it and put it outside. You're just gonna have to make sure it's sealed and safe, like this one. So you can actually, this next one you can leave outside, which is pretty neat. So let's see. Return. All right. So a photocell. What a photocell is it's a switch in a way. It's just like the reed switch, but this one, the switch is the light. So the light is basically telling this how much power to let through. The brighter the light, the more power flows. The less the light, the dimmer, the less voltage going through it. So for this one, we are actually going to need the photocell, a battery, and a connection for the battery. We're going to not use the magnet anymore. We don't need the reed switch. Let's see. I think it's just this and our LED. And of course we're going to need a soldering iron and a glue gun. So what this is going to do is basically, once you're completed, you can actually put this outside and it's going to be in a sealed container. So once you leave it outside with the battery, you could leave it in your garden or anywhere you want to walk through, and it'll basically be a light, and at nighttime it'll turn on automatically. So that's the pretty neat part. You can leave it out and about, and then at nighttime it'll light up away. So you can make a whole bunch of these little guys and have them like in your garden or your walkway, which is pretty, instead of like buying one at like Home Depot or anywhere else, which is gonna run you about like maybe $20 each or 10, and this you can make it for less than like $3, and you could make so many, and it's fun for the kids to make as well, and they could scatter them around their yard, which is pretty cool. So let's see, let's go ahead and get started and let's make this. So once again, we want to make sure our LEDs work, so we're gonna go ahead and test them. So we're gonna use a 9-volt and our LED stripped here, as you guys can see. So this is our positive and this is our negative. So we want to make sure we're plugging it into the right spot on this battery. So here you can see there's a negative, right over here a positive. So now we know which one is which. So red is positive and black is negative. So we're gonna go ahead and plug that in. And all right, so the LED works. That's great. So we can go ahead and get started and continue. All right, so we want to make sure our tips are prepped. These do come prepped, so as you can see, they're like already prepped. They have a little bit of solder. It's not as noticeable, but they already come prepped. They have a shiny glare to them, which is really neat. It's already prepped, so I don't have to prep that one. So I will have to prep these though. They're not prepped yet. And also prep the photocell. So the photocell doesn't have any, so once it has some, we're gonna have tiny beads on there. So I'm gonna go ahead and start on the photocell and give it some beads. Let's see. I'm trying to hide if you can hide. Yes, you can also put this in a lantern. The same idea would work. You just have to have the magnet on you and then just light it up. So let's see. You just have to find the right angle. So you can go ahead and like surprise people or anything like that. So you just have to find the right spot for the reed switch to turn on. So you see it's turning on. It's pretty cool. I want to see if you guys can hear that click. Can you guys hear that? Let's see. Hopefully you guys are able to hear that. That's the reed switch actually clicking inside, which is pretty cool. Alright, so we're going to go ahead and prep this photocell. I'm going to go ahead and grab the soldering iron once again. So when you're using a soldering iron, you want to make sure that your tip is always clean. So you want to make sure there's no guck, none of that on there. So it's always good to have a wet sponge. and just glide over it and clean it. And that helps you make an easy solder. So it makes it way more easy for you and it's less difficult. So we're going to go ahead and prep this side. Let's see. Come on. Alright, so as you guys can see, I already have one bead on there. So that's solder on there. So it's pretty good. Alright, now I'm going to go ahead and do the other side so I can have a nice connection with the wire itself as well. Let's see, almost. Alright, so it's totally fine if you don't have a fat bead like this or anything like that. It's fine if it's thin. As long as there's some solder on the connection here, that means it's going to make a connection with whatever you're trying to connect. So this is totally fine. So, alright, so that's good. Now we just need to prep these two wires here with solder as well. We're going to go ahead and prep that. So let's see. So I find that it's pretty fun for myself to work with electronics. I think any kid that has like a creative outlet would enjoy hands-on experiences like this. So if you want your kid to try out stuff like this, I think it's a great idea. They could start off with simple things like this and make them. They might be really fascinated and end up being involved in robotics. And being involved in robotics nowadays it's pretty cool. You can do so many things doing robotics. And there's many jobs. Like, you know, offering kids that do robotics to get involved with them and go to the next step, like launching satellites, moon rovers, all that cool stuff. So I think it's pretty cool, like making kids get involved with robotics. Let's see, I'm going to go ahead and connect these. So now I'm going to connect, let me show you guys closer. So usually it's always good to add the switch or a switch to the positive side. So the positive is always continuously carrying the current over. The negative side, I wouldn't recommend putting a switch on the negative side. The reason to be is just because it's not carrying the current like the positive is. And the negative is more like ground. So it's not really doing much. So it's always best to put your switch on the positive side of the current. So we can go ahead and solder these together like this right now. So let's see. I'm going to go ahead and solder that. Boom, boom. Let me fold this up. Usually when you're soldering, a helping hand or, well, let me explain what a helping hand is. A helping hand is basically they're like these little claws that you set up, and they basically help hold your items that are going to be soldered together. So they're like little alligator clips. So the alligator clips would hold these pieces together as such, and all you'll have to do is actually just bring the solder over it and complete the connection. But since I didn't grab one, I'm going to have to do it with my hands. So usually, since it's wired stiff, it's very easy. All you have to do is hold it in an angle and heat them both up. So if you have a good connection, should be able to do it with ease. Alright. So usually if you're doing it on your own and you don't have a helping hand, I usually do it with one hand, and when the solder begins to melt and they make a connection, I like to blow on it so it dries up faster and it doesn't tend to like split open. So we're going to test and make sure this is solid. So I'm tugging on it. It's pretty good. It's solid. So we can go ahead and continue and make the other side. Let's see. So I'm going to go ahead and continue this and connect this to the positive side of the LED. Let's see. So we're going to have to put this in an angle and hold this guy down. Alright, so we're going to make sure we get these connected here with solder. They already come prepped, which is great. So we're going to go ahead and put these together. Hopefully you guys can see it from above. Let's see. It's not staying down. Alright, so make sure they're both heated, and when it melts you can go ahead and blow on it to make it have a better connection. Alright. Usually when a connection is like this, it's usually not going to have the best type of connection. Usually when you tug on it, it might break like that. So you want to make sure you have a lot of surface area when you're soldering together. So I might actually have to peel these back a little bit because I had only so much surface area to grab. So that's why it broke on me. So it's always good to tug on your joints when you're soldering. So we're going to go ahead and peel this a little bit. Let's see. Usually when you're peeling the wire, it's best to use wire strippers. But since I don't have any wire strippers on me right now, I'm going to go ahead and use my scissors. And all you have to do is pinch just a tad bit and pull on it. And that'll create a little cut. And all you have to do is pull. So it exposes the wire like that. So now it has more surface area. And as you can see, there's like a little bead of solder there. So that means I still have to add more solder so it has more contact surface. So I'm going to go ahead and resolder this right here and give it more surface area. So let's go ahead and do that. Let's see. Alright, so we can give it more solder there. Let's see. Almost there. Usually you don't have to apply so much solder, but as long as there's solder on the wire, when you're making a connection, it's going to be much more easier. So you always want to make sure you prep it once again. So usually you could find these kind of lights like at, well, ones that are pre-built. You can find them at the 99, Home Depot, or any other place. But it's always fun to like build stuff like this because you know the insides now, and if you ever want to like start messing with electronics and stuff like that, this is a great way to go. Let's see, just need to make sure they heat up and connect. Alright, so now I have a much more better surface. So as you guys can see, now I can tug on it and it's not going to break my last one. So this is great. So it's a good connection, solid. Alright, so next, let's see. So we're going to try to solder this, but yet again, as you can see, the surface area where they're going to connect, it's so small. So it's going to break. So I'm going to show you guys again. Since it's so tiny, it's not going to have the best surface area. So it's going to break on me. I'm going to show you guys once again how that looks, so you guys are aware and don't do that mistake. But it's okay if you do mistakes and all that, because either way you learn from your mistakes and you continue to grow from that. And yeah, mistakes are honestly a good thing, because other than that you won't learn a thing. Let's see, I'm gonna go ahead and solder this. So you guys, oh no. So as you can see, it was trying to connect it, but since it doesn't have much of a surface area, it just broke off the connection. The connection was so weak. So I'm going to try again and see if I can get it on that little bead there. Let's see. Okay. So now you guys can see the bead is on there, but it's so tiny. Usually if you pull it, it might break, but oh, wow, okay. Well, it's actually holding it, so that's a good thing. Alright, nice. But usually you want to avoid little spikes like this, because usually when you're like tugging on it, you might get your finger caught on it and it might cut you or poke you. So you guys can see it's like a very tiny, like, it looks like a thorn. You guys can see it. And it would be really painful if you were to poke yourself with that. So right now we're just going to go ahead and test it and see if this photocell is actually working. Should have tested that before. Let's see. So we're going to go ahead and plug in the battery. As you guys can see, it's lighting up. So if you cover this photocell, which this was its cover, you guys can see it gets dimmer. Let's see if I can get that closer. As you guys can see, it's dim right now. But if I remove the photocell right here and expose it to light, you guys can go ahead and see it's getting brighter. So dimmer. That's if it's covered, and brighter, which is pretty neat. This is a pretty cool type of sensor that it's really simple. It's easy to work with. You don't have to code it. None of that. All you have to do is wire it together. See, you can cover it again. See, it's getting dimmer. Uncover it, it gets brighter. So the more power you have, the brighter this light will be. So it's pretty neat. It's cool stuff. So now I think I'm forgetting something. Oh yes. So I'm forgetting actually to cover these in hot glue. So this makes the connection safer and more reliable on you. So yeah, once again, it's really good to cover these connections with hot glue or electrical tape or heat shrink. Either one works. Whichever one you're comfortable using, go ahead and use. But I like using hot glue because it's easy to use and it's, it's not as expensive. And using the electrical tape for myself right now, trying to wrap these small areas, it's kind of difficult. So I like using the hot glue. So I'm going to go ahead and put hot glue on these guys. I'm going to hot glue it right there. Let's see. Sweet. Now it's covered. Now the chances of it shorting itself out are really, really low, which is such a really good thing. So I'm going to go ahead and do the other side. I'm going to cover these connections real quick. Let's see. Covering it with glue. Now the reason I'm covering this photo cell with complete glue is, let's see, I'm getting glue all over myself. Alright, hot glue is messy, just a warning. Alright, so the reason why I'm covering all of this is because if this were to make contact with the other side, it's going to bypass the photo cell. So the photo cell is not going to work anymore. So it's a really good idea just to cover the whole entire side so it doesn't make contact and bypass this photo cell. So if it bypasses it, that means it's going to light up and stay on all the time, which isn't a good thing because you're going to end up killing your battery at a really, really, really quick rate. So let's see. I'm going to go ahead and cover the other side with hot glue. Have to make sure it's covered in hot glue. It's good to go. All right. This side's good. Now I just have to do the other side. So you can go ahead and do that. Covered in hot glue. Let's see. Usually you don't have to use too much hot glue. The less the better, because that means it's less of a mess. Let's see. Almost. Sweet. Now it's completely covered. As you can see, it's not dry, so it's sticking to my hand. This can get messy if you keep pulling on it, but it's completely fine if the glue gets messy. It's easy to clean up anyways. Okay, so now it's working. So now we're not going to have that short, so if it didn't have the hot glue, it'll be shorting itself out. So, well, it won't really short itself out, but it's going to just bypass the sensor that you guys see here, the photo cell. So if it were to make contact like that with this on there and it has current, it's just going to go right through that. So it's going to make contact. So it's just going to completely ignore this. So I think that's a pretty cool thing to learn. So let's see. Now we're going to hook up the battery once again and make sure everything's working. So great, everything looks like it's working. So now we can go ahead and cover the photo cell. It's dimming up, brightening up, dimming up. So it's working. Nice. So let's see. I'm going to go ahead and disconnect this real quick. Alright. So usually, since this is much more smaller and compact, it's possible that you can put it inside a container like this. So I'm going to go ahead and try to put it in this container here we have ourselves. So let's see. I'm going to put it in here. Usually, if you want to get creative, you can add more LEDs or different colors, which is pretty neat. You could get really creative and add a whole bunch of variety of things on here. So let's see. I'm going to wrap that up and put that here as such. I'm trying to curl it around the cup here so it stays nice and lit. So usually when you're installing your photo cell, you want to make sure it's at the very top. So if it's at the top, it's going to be able to get the light easier and it'll know when to light up itself. Let's see. Let me see if I can put that in there. Put that all inside. Alright, so I'm gonna go ahead and put the battery and connect it. And let's see. So it might trick itself sometimes because when it lights up its own light, it might trigger the photocell. Let's see. So we can go ahead and put that in there. And I'll close it up. Let's see. And then go ahead and close it up. So let's see if I can cover. It's still lighting up. As you can see, it's barely getting any light, and the light is starting to dim, but if you expose it, it lights up. So you can set these up around the outside of your house or anywhere you think it's cool to have some lights. But if it was darker in the room, these would completely shut off. But you can see they're starting to dim if I cover the photocell. But if it's exposed to light, it's going to light up even brighter. So I think these are pretty cool to have around your yard or make the kids make for fun. So today we learned about magnetic and reed switches, which is pretty cool, and photocells. So we did cover the photocell in one of our previous videos, which was, I believe, Shybot. Shybot is one of the robots that have a photocell in it, which is pretty neat. So I would recommend trying both of these for the kids. They're really fun to make, and they're really cheap. All you need is for the magnetic one, you need a reed switch, an LED, and a battery, and just some solder and some hot glue. And it's really fun and easy to make with the kids. And you could always make so many more things with this. So let's see. Let's make sure this guy's working over here. Yep, he's working. So you can usually like set this kind of light up somewhere or anywhere you want actually, and you can just turn it on by a magnet, which is pretty cool. And if you were like to cover this completely and like some a cover or anything like that, you can trick your friends or anybody, and they'll think it's like you're doing a magic trick and you're able to turn on the light with like some type of sorcery or something, some type of magic, you know? You looked into. And this is pretty cool to set around the garden area, which I think is pretty nice. I would say later on in time we can make these more complex and way more. Can you? All right, so the reed switch. What is a reed switch? So a reed switch is basically a switch that is activated by using a magnet. So as you can see here, right here, let's see. So the reed switch is being activated by this magnet. So any magnet can actually just activate this switch. But you just have to make sure your reed switch is pointed in the right direction and you have a strong enough magnet. So a strong enough magnet would usually be like really tough to like open up, and so you can see these are really, really strong magnets. So I could probably move it around on this table here so you guys can see it's a really, really strong magnet. So this is, I believe, 3/4 of an inch wood, so these are really strong magnets. And I believe you can get these magnets at the hardware store, Home Depot, anywhere like that. But the best magnets I would recommend would be like neodymium. They're like really nice magnets, and they're really strong themselves. Because in order for these to be strong, you need to have a lot of these. So that's the downside on nickel magnets. But yes, that's the intel on these magnets. But also when you're using these magnets, you want to make sure you don't have a lot like this. It can get really, really dangerous. And I would recommend parents to help their kids with these kind of magnets, just because they're really, really strong. And if they were to be separated, and let's say like if you were to separate one and you were to let it come in, it's possible to pinch their finger or crush it. But these aren't that strong enough to do that. But it's just best to avoid any injuries while using magnets. Magnets can be dangerous to some point. Let's see, can you try these out in underwater? Yes, you can actually try this one out underwater. You just have to make sure it's nicely sealed up and make sure it's not going to let water inside. You can't use the circuit underwater if you buy a certain spray. I forgot the name of the spray. I think clear coat. You can use actual clear coat and spray everything on there. But you have to make sure that your connections here, they're solid, and you put hot glue on them. And then you can take this underwater and it'll light up. So I think that's pretty cool that you can do that to circuits and all that good stuff. So yeah, The reed switch will be fine underwater. The LEDs, you just have to give them a coat of clear coat, and they'll be fine underwater. So I think it'll be pretty cool. Water sealant. Ah, there you go. Water sealant. Yeah, water sealant is what I was trying to go for. Thank you. But yeah, once you use that, you can actually use this underwater, which would be really cool. And it's like I guess a fun toy to play with in the water if you're trying to play with it. And yeah, this is another one, the light censored LED or light, which is pretty cool. Let's see. Yeah, so I think water sealant opens up like a whole nother door with electronics, and you could take these electronics like on a whole nother level or experience, in my personal opinion. So I think, yeah, using the water sealant would definitely open up doors on making different type of crafty ideas. You can make a whole bunch of other things. Like, I believe nowadays new drones have water sealant inside of them, or they're completely water sealed, and they can go from the water to the air, or they can go completely submerged like a submarine, which is pretty cool. And those drones are, I think you can make one at home if you properly use the water sealant on the drone and on all the circuits, which is pretty cool. And yeah, I think that's a cool idea. Any questions you guys have to ask? Yes, we can see the light turn on. So this one, it's activated by the magnet. So let's see. So the magnet goes by anywhere near it, and it turns on. You don't need a switch or anything like that. Well, the switch is the reed switch itself. So you don't have to physically hit any switch like the one at your house or anything like that. So as you can see, it's being activated by the magnet. So usually the stronger the magnet, the further you can be. So let's see. I want to see how far I can get with this. So I believe this is the amount I have. I have about 3 finger space, possibly. Yeah, about two finger space. But the stronger the magnet, the further the distance, which is really cool. So you can check that out right there. Usually, depending on the angle the magnet is facing, is the polarity it's pushing the little metals here. So let's see. Yeah. Let's see. I'm trying to find an angle that I can get really far away from it, but it's kind of difficult to find that angle. Let's see. Yeah, but you could add these anywhere you want. Let's see. Why is the photocell always staying on? So the photocell right now, it's staying on because it's not picking up as much light. So if I were to take this outside, the sunlight is enough to shut this off. So the photocell would definitely pick that up, and it'll stay off completely. But right now, since lighting is kind of dark in here, it's not like super bright, it's gonna stay on, just a tad bit. So as you guys can see, it's on. Yeah. So if there's any light exposure, it's gonna stay on. But if it were to be completely dark, I'm trying to see it. Like, as you guys can see right now, you see how it's dimming up, so the darkness makes it not light up. So I'm gonna go ahead, and then with the light, it lights up. So I think that's a pretty cool idea. Let's see. I was thinking of a ton of these. Is there a way to... Well, actually, that's a cool idea. I think, yeah, you can make like a design and then run a magnet next to them, and they'll light up. I think that's a really cool idea, because you can get really crafty and make something like a light show. So I think that would be really, really cool. You can just walk around and then turn on your own LEDs and like spook out your friends, or make them believe you have some type of superpower making these LEDs light up. All you have to do is like possibly put a magnet in your shoe or pants, and you just walk by and it'll light up, and you go on so forth with the lights you have lined up, which is pretty cool. You can get really crafty with all of this stuff, but once again, you can help your kids make this, or you guys can make it yourself. There's no age limit. We always have it's always great to learn new things, in my opinion, and we never stop learning, which is great. Hopefully, next time we can create something even cooler and a little bit more complex. But yeah, next time I'll maybe show you guys another cool light trick that I have, or some type of cool setup with lights. I'm fascinated with electronics and electricity, so hopefully you guys see me again. And when do I? 2 more minutes. Okay. So yeah. So hopefully next time I'm able to show you a more complicated circuit, maybe with like another cool trick. So as you can see here, like this is what I was trying to avoid, but luckily it's covered with glue. You can see it's making contact with positive and the negative. They're touching. So if this were to occur, that battery will get fried and messed up. So yeah, it'll mess up the battery and the LEDs inside. So all of those LEDs inside will start to pop and they'll like go bad and you have to replace them. But usually covering it with hot glue is a great way to go. Let's see. Is there an alternative instead? For an alternative on using a magnet, well, it can. Well, the only way the reed switch actually works is actually by a magnetic field. So, the magnet's the only way this would work. So I'm sorry to say, but there's no alternative. But there is an alternative if you use a different kind of switch. So there's always a huge variety of switches that you can use. This is a reed switch. It's magnetic. This is a photocell. So this is a light switch, as you can say. So this uses light. This uses magnetic fields, which is cool. And there's like a whole bunch of other variety of different kinds of switches that you can use, which are pretty neat. There's I believe what other switches there are. There's ultrasonic sensors. Ultrasonic sensors, they can be triggered by motion or distance. So you can actually have one set up here, and then when you walk by it, it will turn on automatically. But it all varies on how complex you're trying to go with the circuit. These are very simple circuits that you could learn and show your kids. Very easy, very fast to make, really cool. But as you move up and move up, these circuits will get much, much more complicated. And that's when you start to use like Raspberry Pis, Arduinos, all that cool stuff. So yeah. So these are like the basics of engineering, which is pretty cool, and it's a great way to start on getting involved with these kind of circuits, which is really, really fun and cool. So my time is coming to like a close end, so I want to thank everybody for sticking with me and continuing and learning all this cool stuff, because I like showing other people what I like to make, so I think this is really cool. Well, thank you everyone, and follow us on I think Facebook, YouTube, and on Twitch. I think it's pretty cool. Hopefully you guys subscribe, and hopefully you guys want to watch more of this and see more content like this. So yeah, so thank you everyone, and have a nice day.